So there's actually an error on the answer key for question 3. I will send an email about this and update it. Some of these are relatively straightforward. So part A, all you're doing here is you're making the tosylate in situ and then reacting that with sodium azide, and then you get the azide out of that. That's on the answer key. I'm not going to rewrite that for you. The issue in the answer key is that hopefully you can recognize, and I did not recognize when I put this together, nor did Ruzva, who actually wrote this down, that this is a tertiary substrate. This will never undergo SN2 reaction. This is a strong nucleophile or strong base. So it's either going to be SN2 or E2. The most likely position for E2 is one of these 3 hydrogens. So your product from this reaction will be this. You will also get a small amount of this and this. Okay. This is a very simple SN2 reaction. It's a secondary substrate. It's a very strong nucleophile. So you're just going to have stereochemical inversion at this center, standard backside attack. Sodium azide, again, strong nucleophile, good leaving group. So the primary product you're going to get out of this is stereochemical inversion at that position. So this is your primary product. Alright, so this is actually a really interesting question here. The key with this question is to be able to draw the conformation of this molecule, and that is that it is locked. And this is an example of it would be very useful to have models to show you this. So it's a 6-membered ring, and then here you have a 1, 2, 3, 4, 5-membered ring fused together. What that effectively does is that your iodide right here is locked in the axial position. Right, so it's predisposed. You're using a strong base. This is a bad nucleophile, but it's a strong base. You're going to remove this hydrogen. Let's kick down here. So your product out of this will be this molecule. Okay. Alright, and again here, what you have to recognize is that this is the only really good leaving group right here. So you get stereochemical inversion at that position. It's a standard SN2 reaction.